Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 93. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is pyridine which attached with second position alcohol. You are using two different reagents. They ask you to find the product. The reagents are methyl iodine and base and diazomethane. Here products are mostly differ in the methylation. There are the three possibilities here. One is N substitution or O substitution or ring substitution. Really the question is about reagent versus selectivity here. The answer is C. Let us see how. Let us see the first reaction, which is P. P, you are using the base there. Base subtract the proton. You have anion formation. Next step, you are using the methyl iodide. Here anion has to be quenched. So O minus travel through the system and N possesses the negative charge there. So N possesses the negative charge and you are attacking with methyl iodide. So methyl iodide attacks the N. So you have the product N methylation. The next reaction, you are using diazomethane. Diazomethane CH2 possesses the negative charge there. If you use any alcohol, it abstracts the proton, it becomes CH3 and N2. The N2 has positive charge and it is a very good leaving group. So N2 leaves, so O methylation happens there. Here, the role of alcohol is to donate H plus to diazomethane. So the answer is clearly C. P product is N methylated one, Q product is O methylated one. Here you have to learn two important things. The same reactant, only the selectivity established by the reagent. The NOH and methyl iodide leads to the N-methyl attachment. Similarly, diazomethane is just a methyl donor here, so O methylation occurs there. Then the question number 2. The starting metal is cyclohexanone, which is in the conjugated form with alkene. Then you are using two phenyl group. One is with cyanide attachment, you are using the light. They ask you to find the product. The products are suggest that the 6-member ring become 5-member there. How this conversion happens is by migration of the phenyl group. Whether the cyanide phenyl is moved or just a phenyl is moved or without the ring contraction cyanide ring is moved or not. So the question is really about the intermediate stability and its reaction there. The answer is B. Let us see how. The starting metal you have conjugated ketone, you are using the light. Light is weakened in the double bond which is in the conjugated form. So instead of ketone, the double bond is weakened there. You have 1,2 diradical there. Then the next step, the radical has to be stabilized. So any one phenyl group moves and stable radical will be formed. Here when compared to phenyl migration and cyanide migration, the cyanide migration leads to a radical near phenyl one, which is very stable. If phenyl moves, the radical forms cyanide. The radical formed near cyanide is very much unstable because the radical is T-stabilized by electron withdrawing group. So cyanide groups moves there. Here radical has to be quenched. How it will be quenched? Just forming the CC bond there. So the unusual strained bond, because to quench the radical the strained bond is formed there. Here you have to learn two important things, which is selectivity. First thing is migrating ability. You have to decide when the group is migrate, the stable intermediate is formed or not. Here radical is there. If phenyl group moves, unstable cyanide radical form. If cyanide moves, stable phenyl radical forms there. Here phenyl radical can migrate to 1 or 2. So why the 2 migration happens there? Because one radical is not always available due to the resonance there. Because radical moves among oxygen and carbon, so the availability is less there. Then the question number 3. The starting metal is benzene, it is attached with 4 fluorine groups and the side chain it has ketone attached with ester. Further it contains alkene with OET which is ether. Next you are using the propyl alcohol. In the second position you have amine there. They ask you to find the product. The products are mostly where the reaction is occurred, where the amine is attacked. Whether the alcohol is attacking the ring or amine is attacking the ring. If amine attacks, the cyclization happen or not. there can be a 5-member amine or 6-member amine or the heterocyclic amine. So the question is really about where is the reaction center and how the ring closure occurs there. The answer is D. Let us see how. The starting metal you have many fluorine, but the fluorine and the second position is a very reactive one. It can be removed because it has more resonance stability when the nucleophile attack there. Here when compared to alcohol and amine, amine is a very good nucleophile because of its electronegativity. So amine attacks, the electron donation occurs there, and you have negative charge near the carbonyl carbon which is in alpha position. The charge gets to be quenched, the charge travels, and you have fluorine removed there. Because fluorine is a very poor leaving group, but driving force here is aromaticity. So fluorine leaves with the help of aromaticity. Here there is a possibility of 6-member formation because you have OET leaving group and there is a possibility of 1,4 addition there. So amine can attack in the 4th position. So amine attacks, the charge travel. The charge again has to be quenched. So charge travel back and OET leaves. HETO is a very good leaving group as a negative charge. Here the driving force is charge quenching there. So the answer is clearly D. Here you have to learn two important things. One is fluorine also can be eliminated because the driving force for fluorine elimination is the aromaticity. The strong driving force required for fluorine elimination. Second thing is nucleophile. The electron density with less electronegative atom is very good nucleophile. When compared to oxygen, amine is less electronegative. So amine is a very good nucleophile because nucleophile is basically Lewis base, it should donate. Then the question number 4, the starting metal is 1,3-diketone and the next step you are using the chlorinated acetaldehyde. So next step you are using aqueous NaOH as the reagent there. They ask you to find the product. The product suggests ring is closed there. The ring is closed with which ketone is important here, whether the first ketone is eliminated or third ketone is eliminated or simply the aromaticity established there or not. So the position of ketone is the real question. So from the reagent to product you might guess definitely ring closure is occur which is in the regioselective fashion. The answer is A. Let us see how. The starting metal you have diketone. In the middle you have active methylene group. So we are using a base, so the proton abstraction will be there. So proton is subtracted, you have negative charge. So negative charge is there. Next step you are using the ketone. Negative charge is there, you have the chlorine leaving group. So the attack is happened on the chlorinated carbon, not on the carbonyl carbon. So it attacks, new CC bond is formed. So next step hetoenol tautomerism occurs because of the conjugation established. So O minus is there, it attacks the ketone again. Here alcohol is there, nearby hydrogen also there. To establish the aromaticity you have to eliminate the water there. So water will be eliminated, you are re-establish the aromaticity. Definitely the answer is A. Here you have to learn two important things. The reaction center not always a carbonyl. The carbon with very good leaving group is the reaction center. Here the chlorinated carbon is the reaction center here. Second thing is aromaticity. Aromaticity is the most stable form among many. So you have to establish the aromaticity if you have ring there. Then the question number 5. The starting metal is in question. You are using the light there. The product is fused tricyclic system. One side is benzene, other side is cyclohexene with 2-methyl group. Then you have diketone. The reactions are suggested here. The diene and alkene, and where the diene and alkene, whether diene and dienophile. The question is really about where the diene come, where the dienophile come, whether it is come from the ring or whether it is come from the separated product. So there are the 4 possibilities, where the alkene and where the diene. So you have to understand the reactant nature versus the product. The answer is D. Let us see how. The starting metal is in the question. To identify the starting metal is easy because the Diels-Alder reaction actually it is between light, diene and dienophile. Dienophile should contain the electron withdrawing group. Diene should contain the electron donating group. So there is a reaction between electron rich center and electron poor center. So the proper reactants will be cyclohexenone and separated diene there. It fused to form the product D. Here one another thing is aromaticity is not established by cycloaddition because you are forming a new bond. Only one double bond will be there. There is a no conjugated double bond. So benzene side is not at all possible there. Here you have to learn two important things. One is diene and dienophile. Diene should be with electron withdrawing group. Dienophils will be with electron donating group. Here electron withdrawing group is carbonyl, electron donating group is methyl there. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.